And welcome back, students. Let's go ahead and continue to discuss polymorphism. Let's go ahead and have our first look at the clone method. Remember, we have kind of discussed the clone method before, but we haven't really talked really much about it. Now let's go ahead and take a first kind of glance at what it is and what it does. So getting started, every object inherits a method named clone from the class object. Remember, class object is kind of like one of the big super objects that's out there in Java. Well, we've talked like they get like the equals method, they get the toString method. Well, they also can get the clone method. Now, what's interesting about the clone method is that it has no parameters. And what's supposed to do is return a copy of the calling object. However, the inherited version of clone was not really to be designed to be used as it is. Instead, you're expected to override the definition of clone with the version appropriate for the class you're defining. So notice you can't just say clone, because otherwise what it does, it tries to use the object. Instead, you have to redefine it. So every time you want to use it, you have to redefine the clone method. You can't just use it. Kind of like how we look at when we look at, like, for example, our toString and equals methods. A lot of times we override those. Similar thing goes on here. Now, the officially sanctioned way to define the clone method is a bit complicated and requires material not covered within this chapter scope. We'll talk about that later on. But for what we are worried about for today, we're just going to kind of use a little bit of a hack. So in this section, we're going to describe a simple way to define clone that will work in most situations and allow us to discuss how polymorphism then interacts with the clone method. Right, so as I already mentioned, the clone method has no parameters and should return a copy of the calling object. Now, the returned object should have identical data to that of the calling object, but it normally should be a different object, so an identical twin or a clone. Now, you usually want the clone method to return the same kind of copy as what we have been defining for copy constructors, which is known as a deep copy. Now, the clone method serves very much the same purpose as that of a copy constructor. But as you will see in our pitfall limitation of copy constructors, there are situations where a clone method works as you want, whereas a copy constructor does not perform as desired. Now, as with other methods inherited from the class object, such as toString and equals, the clone method needs to be redefined or overridden before it can perform properly. So the heading for the method clone in the class object is as follows: protected object clone. If a class has a copy constructor, you can define the clone method for that class by using the copy constructor to create the method returned by the clone method. For example, consider the class sale. The following definition of the clone method can be added then to the definition of sale. Public sale clone, return new sale this. Now, when you're using a copy constructor, obviously this is not, as we mentioned, the officially sanctioned way to define a clone method. In fact, Java documentation says you shouldn't define it at all this way. However, you'll notice in most situations it's going to work correctly. And some people, some authorities on Java will even say this is acceptable. Of course, I want you to make sure that you know, according to the Java documentation, two different things. Now, in a later chapter, as I already mentioned, we will discuss the official way of defining the method clone when we introduce the clone interface. So that's going to be near the end of the year. All right, now note that as we define the method clone for the class sale, the method clone has sale as its return type and is given public rather than protected access. Now, despite these changes within the method heading, this definition overrides the method clone inherited from the class object. So remember, it's protected when it's an object, but when we use it for our override, we change it to public, which is perfectly acceptable. As we know in the previous chapter, a change to a more permissive access, such as protected to public, is always allowed when you're overriding a method definition. Remember, we can always make it, more permissive, but we can't make it less. So I can't go from protected to private. I can't do that, but I can go the other way. Now, changing the return type from object to sale is also allowed because sale, and every other class for that matter, is a descendant of the class object. All right, and if you remember from our previous chapter, this is an example of what's known as a covariant return type. Now, the clone method for the discount sale class can be defined similarly. Public discount sale, clone, return new discount sale this. If we had other methods, such as like a super discount, it would be the exact same format. Return new super discount this. All right, so here's our first pitfall to discuss today. Sometimes the clone method return type is an object. All right, and this mostly applies because previously in prior versions of Java, prior to 5.0, Java actually did not allow covariant return types, and so did not allow any changes whatsoever in the return type of an overridden method. In those earlier versions of Java, the clone method for all classes had object as its return type. This is because the clone method for a class overrides the clone method of the class object, and the clone method of the class object has a return type of object. So if you encounter a clone method for a class that was designed and coded before version 5.0 of Java, the clone method will have a return type of object. Obviously, we're in a lot later version now, but in case you come across like some legacy code, if you ever go into career programming and you come across some old legacy code that might be using an older version, this would be good to know. Because when you're using such older clone methods, you will need to typecast on the value returned by clone. So for example, suppose the class old class was defined for Java 5.0. If original is an object of the class old class, then the following will produce a compile error message. Old class copy equals original.clone. The problem is that original.clone returns a value type object while the variable copy is of type old class. To correct the situation, you must say a typecast as follows. Old class copy equals old class original.clone. Now, occasionally you may still encounter this problem with classes defined after Java version 5. In versions 5.0 and later, it is still perfectly legal to use object as return type or clone method, even though that's not for return type. Now, when in doubt of whether it's an object or a class specific, you can still typecast. It's not going to cause any harm. Right? All it's going to do is just like if you're, let's say it's a sale, and you just throw the sale typecast on there, it's not going to do any harm. It's like if you look at parameter types, if you had an int and you just typecast an int, it doesn't change anything. It just keeps it as an int. So for example, the following is legal for the clone method of class sale defined within the previous section. Sale copy sale equals original sale.clone. However, adding the following typecast will produce no problems. Sale copy sale equals sale original sale.clone. Right, so you notice that they are pretty much identical, except for that the second one has the typecast. And again, that's not going to affect the value in any way, shape, or form. It's just that it's a typecast. Right? And because of the typecast is what we're desiring, and in this instance, it's still sale, we're good to go. And this would only apply here more than the newer version of Java. Older versions, you have to do this, so you'd have to put sale there. But for our new versions, we can just do this. Now, if you're in doubt about the clone method of a class, obviously it doesn't hurt that you can put the typecast in there. All right, now here's our pitfall for the limitations of copy constructors. I had mentioned that we were going to discuss this. So as we can see, copy constructors are going to work well in most cases. However, there are situations, naturally, where they do not and cannot do their job. And this is why Java favors using the method clone in place of using a copy constructor. And what we're going to do is we're going to do a simple example of where the copy constructor does not do its job, but the clone method does. So for this discussion, let's just assume that the classes sale and discount sale each have a clone method added. We're just going to use the one that we had defined previously. Now the definitions, as I mentioned, are in the previous slides, so let's go ahead and take a look here. So suppose we have a method with the following heading. This supposedly returns a safe copy of A, that is, if B is the array returned, then B of I is supposing an indent copy of A of I. So here we have public static sale, array, bad copy, sale, array A, sale, array B equals new sale, array dot length. For int I equals 0, I is less than a dot length, I plus plus. B is of I is equal to new sale of A of I. Now if there is a problem here, and then it's supposed to just return B. So let's look at that problem part. Now, if your array contains objects from a derived class of sale, such as objects of discount sale, then bad copy A will not return a true copy of A. Every element of the array bad copy A will be a plain old sale because the sale copy constructor produces only plain old sale objects, and no element in bad copy A will be an instance of the class discount sale. Instead, if we use the method clone, things will work out as they should. Now, the following is the correct way to define our copy method. Public static sale, good copy, sale array A, sale array B equals new sale, A.length, for int I equals 0, I is less than A to length, I plus, B of I is equal to A of I dot clone, return B. You'll notice that this is very similar to this. Right? Very similar. The only difference is pretty much right in here. Right? Here I said new sale array of I, whereas in our new one, I did A of I dot clone. So I'm using the clone method here. All right. Now this is because of late binding. All right. That clone will end up working. So late binding, if you remember, is polymorphism. All right. A of I dot clone always means the correct version of the clone method will be used. Now, if A of I is an object created with the constructor of the class discount sale, A of I dot clone will invoke the definition of clone given within the definition of the class discount sale. Now, if A of I is an object created with the constructor of the class sale, A of I dot clone will invoke the definition of clone given within the definition of class sale. And this is illustrated in our copying demo class. So I'm just going to flip over to Eclipse real quick. And here you can see we have our copying demo. So I have my sale array right here. I've defined hard to find array of 0, array of 1. So I have a sale object and a discount sale object. And you notice that those are both within the sale array. And I can do that because even though this is technically a discount sale, the sale object, remember, discount sale is a type of sale. Now, if this was a discount sale, probably going to use sale. But because it is a sale object and this is a derived class, we're good to go. All right, then I have int of I. Sale array B is my bad copy of A. This is now a print line with copy constructors. For I is equal to 0, I is less than A to the length, I plus. And what it's going to do, it's going to print out the value of A of I and B of I. Right. This is the not print line. And then I'm going to do B equals good copy of A. And I'm going to use the clone method now. Right. And so here I have very similar things. I'm going to print those out. Now, if you look down here, we have the bad copy and good copy methods. So the bad copy is just like that first example we saw. You'll see right in here, I have B of I equals new sale A of I, so that's where my problem is. And the good copy, if you notice, it's just like the other one we saw, B of I equals A of I dot clone. Right? And so what this does, we'll return it, of course, the safe copy of A. And you can see right here, it says that is, if B is the array returned, then B of I is an independent copy of A of I. Whereas right here, you can see, suppose it returns a safe copy, but it doesn't. That is, if B is the array returned, then B of I is supposed to be independent of A of I. Right? But if we run this, right, we look at our copy constructor here. A of 0 is equal to atomic copy mug, price and total cost 130. B of 0 is atomic copy mug, price and total cost 130. A of 1 equals invisible paint price equals $5, discount 10%, total cost 4.5. B of 1 equals invisible paint price and total cost 5.0. Alright, so with the clone method, we get A of 0 equals atomic coffee mug price and total cost equals 130. B of 0 atomic coffee mug price and total cost equals 130. A of 1 is invisible paint price equals $5, discount is 10%, total cost 4.5. And here we have invisible paint price, $5, discount 10%, total cost 4.5. Now, where you'll see that this causes an issue is right here with, like, for example, the discount sale. It doesn't affect the sale item because remember A is sale, B is discount sale. So it doesn't affect sale. Right, that one came out fine. But the discount sale is where we start running into issues. Because you'll see that this just stayed as $5. Right? With the clone method, this became 4.5. Right? So again, those are some of those little finite issues that we can kind of run into sometimes because it doesn't necessarily derive the correct object. Right? Remember, A of 1 should be discount sale, no matter what. And it only really applied that discount sale here to the one object. So in that example, you saw that we defined the method clone in terms of copy constructors. We have public class clone, because new sale this, return new discount sale this. So the question to ask then is, why is using the clone method any different than using a copy constructor? Well, the difference is simply that the method creating the copy of an element A of I has the same name clone in all the classes, and polymorphism works with method names. The copy constructors named sale and discount sale have different names, and polymorphism has nothing to do with the methods of different names. Now, of course, we will have more to say about the clone method later on when we discuss the clonable interface. All right, and that's going to kind of wrap it up for today, folks. So, until the next time.